Hello everyone, and welcome to another Mini Sky Tonight. And to continue with our solar system tour, we're now discussing the planet Venus. It's kind of windy outside today, so hence why I put on my little space jacket today. So just to warm up a little bit, and I wanted to discuss with you one of the hottest planets in our solar system. So let's dive into this beautiful beacon in the sky. So let's discover the history. Like Mercury from the previous week, in fact, I'll leave a link in the description if you wanted to check out Mercury, the first planet in our solar system. Mercury and Venus have been observed for thousands of years. In fact, the first recorded observations was back in 650 BCE by the Mayan. In fact, Venus was an important planet to their culture because they used it not only for their calendars, but they also aligned some of their buildings based upon it. And they knew how to align their calendars and their time schedules based upon the orbit of Venus. So it's really cool to see how one particular observation of a planet influenced an entire culture. In fact, speaking of different cultures, it's named after the Roman goddess of love, Venus, but it was basically taken over by the Romans, which was originally Greek, and her name was Aphrodite. In the Sumerian, they was called Inanna. And in Chinese, they called it the gold planet. And it kind of makes sense because it's a really bright beacon in the sky. Egypt called it two different planets because they thought it was two different entities rather than just one single planet. They thought the early morning and the early evening planets, as they thought it was, were two different entities. So it was Tiao, and I apologize if I butcher this. I am not good with Egyptian deities, so just bear with me. Tiao Moteri and Oeti were two different entities. So the T name was in the early evening and the O name was in the early morning. So they thought there were two different entities. Like they believed that one would poke out in the early evening like they were playing a game of Marco Polo, so to say, and they were trying to find each other rather than thinking it was one particular planet. The Japanese called it the metal star because they believed that each of the different planets had an element associated with it. And the Maya called it Chakik, which means the great star. And they enveloped their entire culture around it. In fact, we even envelop our culture around it as well. If you look at the famous painting by Van Gogh, the Starry Night picture that has gone across the internet in different forms, you see the moon in the top right, but that bright star near the tree is Venus. Because he talked about one particular night during his lifetime when he checked it out and they were able to match the sky on this particular night, and that was the planet Venus. So let's discuss some of the basic information of this planet. It's sometimes referred to as our sister planet because she's similar in size and density to Earth. She has nearly a circular orbit like Earth, and she has a lot of different features that are very similar to Earth. But I like to sometimes call her our hot sister with problems. Yeah, she may be similar in size and have a similar orbit and have other different features that are very similar to Earth, but she is far from exactly being like Earth. 1 year is roughly about 224 days. It would make sense because Venus is a little closer to the sun compared to the Earth, so it has a shorter year than the Earth. But 1 day, however, is completely different. 1 day to go from sunrise to sunrise on Venus is 243 days. Venus rotates slowly and it rotates backwards. So rather than having the sun rise in the east and set in the west, the sun rises in the west and sets in the east. That's if you could see the sun on Venus, but we'll get to that in a minute when we discuss about its atmosphere. So it rotates backwards. And this was kind of counterintuitive, and astronomers were trying to understand why it rotates backwards compared to all the other planets which rotate counterclockwise. This is the planet, Venus rotates clockwise. And astronomers believe, given the different structures of Venus and everything, it's a combination of early bombardment when it was first formed, like something smacked Venus in such a way to where it rotated in the opposite direction, as well as basically tidal gravitational pulls from the sun and influences of its atmosphere that basically caused it to slow down its rotation so slowly. It would have rotated similar to that of Earth, but it's due to gravitational pulls and atmospheric turbulence on Venus, as well as early bombardment, that slowed the planet down and caused it to rotate in the opposite direction. Venus is roughly about 67 million miles or 0.7 astronomical units away. And we use astronomical units in astronomy to discuss about different cosmological distance. In fact, if you want to check out a video I did about why we use different cosmic rulers, I'll leave a link in the description up here. Now, I mentioned Venus is the hottest planet in our solar system. It is 900 degrees Fahrenheit day and night. This sometimes confuses a lot of people because they think, oh, well, since Mercury is so close to the sun, it should be much hotter. When in actuality, it's Venus, and it has to deal with this atmosphere. It has a runaway greenhouse effect, and I'll discuss about that a little bit later. As I mentioned, it's sometimes referred to as the early morning or early evening star, because since Venus, like Mercury, it's so close to the sun, as you can see in this diagram here, its orbit doesn't travel very far from the sun. So as the sun sets, chances are you'll see Venus relatively close to it, or as it starts to rise, you'll see Venus close to it, depending upon where it is in its orbit. You never get to see Venus or Mercury at midnight because it has to be near the sun. And Venus is important in terms of astronomical history is because Galileo discovered that Venus goes through different phases, kind of like our moon. And the way it was able to tell it was going through phases is because since Venus is so bright and its atmosphere reflects a lot of light, he was able to notice it goes through different phases like sliver, it went through crescent to almost full to half and so on, but he never got to see a full Venus. And it was that bit of information that he was able to present to the church, and Galileo presented, instead of having an Earth-centered system, why not have a sun-centered system? All right, so let's dive into the surface of Venus. It's hard to see the surface of Venus because, as you can see in the previous image, it's this beautiful kind of cream-colored marble. And it's kind of difficult to see beyond the surface. So in order to see the surface, we had to use different techniques to be able to image it. We used, on the Magellan spacecraft, radar. So kind of the technology that was used in submarines, we were able to put it on to a spacecraft, and we were able to image the surface of Venus and see some unique details. It's been volcanically active, and it was first observed in 2008. Now, what I mean by first observed is like it's been going on for a while, but we first actually got to see volcanic activity in 2008. We've seen traces and hints of it, but now in 2008, we got to actually see volcanic activity. So it's even volcanically active to this date. Astronomers believe that it was once volcanically active and now it's dormant and or it was extinct, but now as of 2008, we can say, no, it's still going on. And it has a relatively smooth and young surface, and that's because of basically volcanism basically covering any type of craters or anything, basically new surfaces being made constantly. But one of the things that kind of bothered astronomers when they were looking on the surface is that where are the lava flows? They're seeing a new surface being made, and they're hinting that possibly there was once water on it because they see rivers and everything that were once there, and possible low, deep areas that could have been lakes and oceans during its early formation. But why don't we see like lava flows like what we see in Hawaii? So it's one of the mysteries that we're hoping to be able to discover. And of course, the largest volcano on Venus is Mount Mons, and it's as big as the big island of Hawaii. So even the volcano here on Earth is very similar to that of here in Venus. So it's very similar. So now here's the beautiful view of Venus. So as you can see, there's not a lot of craters on here compared to, say, Mercury or our moon, where you see tons of craters because it has an older surface. A lot of the surface has been wiped away, covered in volcanoes, and some of those spots that you see are calderas. So let's dive deeper into Venus. It's very much like Earth, but it has a thicker mantle. The mantle on Earth has a little bit of water vapor and such mixed in with the mantle to give it kind of like a liquidy kind of flow, whereas in the mantle on Venus, since there's not a lot of water, it's kind of much thicker to get through. So because it's much thicker, there's no tectonics that we know of as of yet. So we're not seeing like plate tectonics or shifting of plates or earthquakes of that nature. It's the second densest planet after Earth. Second densest planet after Mercury, forgive me. It should be Earth, Mercury, and then Venus. So there was a typo right there. But it does have a very little magnetic field, and it's due to its slow rotation. Hence why we were surprised when Mercury had a bit of a magnetic field, even though it doesn't rotate very fast at all. And astronomers are trying to understand, okay, why for a planet that's roughly about the size of Venus, why doesn't it have a magnetic field? And is the magnetic field affecting the atmosphere of Venus? So speaking of atmosphere, let's talk about this big elephant in the room. Why is Venus the hottest planet in the solar system? As I mentioned, it has a runaway greenhouse effect. So the greenhouse effect is basically when light and heat come in through the atmosphere, and some of it escapes, but some of it doesn't and stays in and is continually trapped, like a greenhouse. So when light and heat and energy come in through a greenhouse, which is this big, huge building with nothing but glass windows and glass walls, it traps the heat inside the building, so that way the temperature is constantly hotter than it is on the outside. And this is good for many greenhouses. So like if you have plants that you're trying to cultivate that need higher temperatures compared to where you are, say it's like in the middle of the winter and you have 20, 30 degrees outside, but if you want to have plants that need the constant 70 degrees, you can use a greenhouse. Now, a runaway greenhouse effect is something completely different. The heat can't escape. It's basically a house on fire with the windows forever closed. There's no way for the heat to escape. Because greenhouses, they have vents to allow heat to be able to escape as needed to keep the temperature at a steady level. In Venus, whatever heat is trapped in there stays in there. And so basically it keeps heating up and heating up and heating up, hence why the water that was once on Venus has evaporated. And its atmosphere is composed of 96% of carbon dioxide. So you could not breathe on Venus. You would be poisoned. You would die of carbon dioxide poisoning on Venus if you had to breathe the atmosphere. And there's 4% other gases like nitrogen and a bunch of other sulfuric acids mixed within the atmosphere. So you would be burned and poisoned by just the atmosphere alone. And the air pressure is so great, it's 96 times that of Earth. That would be like feeling the pressure 1 mile below the surface of the ocean. So if you were basically be 1 mile deep underwater, that would be the equivalent pressure you would be feeling on Venus. So you would be poisoned, fried, and squashed on Venus. It is quite literally a hell of a planet. So hence why I mentioned our hot sister with problems. You could not survive on this planet. And any instruments that we have sent onto this planet, whether it's from the United States or Russia, has not survived at all. It has acidic clouds, and its cloud structure, since it's so thick, it's been known as a supercritical fluid. basically it's reached a critical point where it's not in any unique state, whether like gas or liquid or solid. It's in its own unique sublimation stage. That's how crazy it is. And also, Venus does have wind. So it's hot, dry, and windy constantly on Venus. And the atmosphere is so thick that only about 5% of sunlight gets through the atmosphere. So imagine like a really heavy overcast day, and that's what you would constantly see on Venus. Now in 2020, they possibly detected phosphine, which is basically the offshoot of an organic compound, so there could have been potential for life on Venus, but that particular paper has been up for scientific debate, and some studies have shown that that was not the case, so hence I put the question mark up there. If you want to follow along with that particular paper, go check it out. It's basically a scientific nightmare is all as I'm going to say, is because a lot of things were shady when they were doing their observations, and I'm going to just leave it at that. So if you want to follow along with it, go check out the original paper published in Nature. All right. We have visited our sister planet with over 40 different instruments. The Venera spacecraft. So yes, we were the United States was the first to land on the moon. Russia was the first to land on a planet. They had the Venera spacecraft, which is basically Russian for Venus. So they're basically the Venus spacecraft that they sent over 16 different spacecraft to Venus to study it. The Venera 1 and 2 was mostly just flybys to take a look at the planet itself, to kind of take a look to what areas would be good to be able to put it into something in through the atmosphere, as well as to understand some of the dynamics of getting things into orbit. Number 3, they were hoping to be able to be the first one to go through the atmosphere, but due to instruments failing, it crash landed on Venus. So we have landed something on Venus, but not intentionally. And then 4 through 6 were atmosphere dives, to where they got in close enough to where they were able to go through the atmosphere and then zip out. 7 through 9, they landed on Venus. In fact, the image that you see right here is the first picture on Venus. And it's one of a few different images that we were able to get on Venus because the instruments started to fail. The pressure on these poor instruments, as well as the high temperatures, were starting to degrade the equipment incredibly fast. Now, 10 through 14 lasted longer, and they were trying to get them to last longer in these different pressures, but they had the problem where they couldn't take images because of lens cap failures. Now, the lens caps on certain types of cameras, if you look inside a camera, you see this little shutter. And the shutter, or lens cap in this particular case, allows the shutter to go open and close. And the sensitive equipment to allow a shutter to go open and close can fail easily, especially if it's in extreme conditions like what it was on Venus. Even though they tried to be able to manipulate the equipment to be able to have several fail-safes, even those fail-safes failed. That shows you how extreme of conditions it is on Venus. And then their last two, 15 and 16, they just decided, rather than just to try to land on Venus, they made these orbiters, which used radar so they could do some more imaging on it. The United States sent over Pioneer Venus. Even though we took some images from the Mariner spacecraft that went to Mercury, we finally sent a spacecraft and probes to Venus with the Pioneer Venus missions. And of course, Magellan was the first one to officially map the whole surface of Venus using radar. And then of course, Venus Express was able to study the atmosphere and some of the surface features, how we suspected that there was once oceans on Venus in its early stages of its formation, and much, much more. And the current spacecraft that's in orbit right now is Akatsuki Venus Climate Orbiter, where it's trying to understand why Venus has the wind patterns and structures, and why some of its winds are increasing. The winds on Venus are suspected to be over 400 miles per hour in some cases, and it's crazy to think for a planet that rotates so slow, it has high windy conditions. So, for this crazy and extreme planet, where can you see it? Where can you check out some of the different phases that Galileo once saw once upon a time? Well, in the early morning skies, if you look over towards the east-southeast area, you'll see an incredibly bright star close to sunrise. And of course, you'll kind of see the faint planet Saturn really, really close to the horizon, but you'll definitely prominently see Venus as the sun starts to rise. So if you have a pair of binoculars or a telescope, go check out this bright planet. So that's all I have for our planet tour of Venus. Next time I'll talk over about Mars. If you have any questions or comments, leave it down in the comments below. If there's a topic you would love for me to cover over sometime in the future, leave it down in the comments as well. Also, as we're starting to get close to Valentine's Day, or if you're looking for some ideas, I recommend Earth to Sky Calculus. It's a group of students that sends high altitude weather balloons up into space to take research data material. And sometimes in their payloads, they send items up into space. And they sell those items to help continue their research. So you can officially buy something that has been in space, as well as help some students be able to continue their research and get scholarships to go to college. So until next time, stay safe, stay healthy, and as always, never stop learning.